Afternoon, everyone. Welcome to the 4398 Capstone final project demo. This is section 2. We're really excited to show off student work. I can see we keep getting more and more guests and students. So first, I want to talk a little bit about what is the CIS Capstone. The CIS Capstone is the culmination of all of the students' previous coursework and outside experiences to build a substantial software project. This presents a lot of challenges because working in a big team is, kind of challenging. So students heavily collaborate using Jira project software project management tools. They also use GitHub for managing all of their code and integrating these things. And so whether it's planning using Agile story pointing or using any of these tools, it's not just the actual coding. Many students this semester have chosen to do hardware projects, which present completely different engineering challenges that maybe we don't cover in the CIS curriculum. Whether it be soldering, 3D printing, and working with embedded systems such as the Raspberry Pi microcomputer. Students spend a lot of additional time outside of this class working on these projects, spending a lot of time in my office. The enthusiasm has been really, really strong this semester. We also ask students to document all of their project code, which is from proposal to requirement specification to design documents, architecture, and an API design. We use a website builder known as Docusaurus to maintain all of these assets, which that also presents even more challenges for the students. So we have 5 really great projects. We've already presented 2 this morning. So now we're going to go straight into the second one. Jump through here. So now we are in section 2. We're going to start with Wildlife Odyssey. Then we'll follow up with PhillyGPT, and then we'll finally end it with LastPad. We're really, really excited. So I can see there's some energy over here to just get started. So welcome Wildlife Odyssey.
Hello, everyone. Welcome to Wildlife Odyssey. My name is Alex again. My name is Luigi. I'm Brian. My name is Andy Trent.
I'm Theron Halty.
And I am Eddie Pike.
So, buddy, tell us, what is this game that you've been talking about?
Well, this game is called Wildlife Odyssey, and it is a nice little 2D side-scroller where you play as one of 3 different animal characters with all sorts of attacks and fight enemies.
Well, it's as cool as you've made it seem. It's going to be a lot of fun. Why don't we play a game?
Sure. I'll go ahead and log in, but you can go ahead and play as a guest for now.
Okay, that sounds good to me. So I'm going to play as guest. And I guess I can always go back and make an account if I want to, right?
Yes.
Okay, I logged in as a guest. So now I see a bunch of options for creating and joining a room.
Yep. I'm going to go ahead and click on Create Room, and then I'll make a room called Waffle. Now, if you want to join this room, all you have to do is click Find Room, and then click on Waffle.
Oh, can we join too?
Sure. You guys can all join if you want. Let me know once you're in. We already got 4 players in. Are we waiting for anyone else?
Yep.
All right. Then I'm going to go ahead and click Start Game.
Wow, look at all these characters.
Yes, you can select between one of 3 different characters. First, there's Gary. He's a dog who wields a sword, so we have lots of long-range attacks that can keep the enemy away from him. Then there's Omar. He's a boxer, so he's more of a close quarters kind of person. So all of his attacks are short range and fast. And then there's Stephanie. All of her attacks are projectiles. I'm going to go ahead and play as Stephanie. So I'm going to go ahead and type my name in this box. And then I'm going to go ahead and click select.
Whoa, I can see everyone here now.
All right, but how do I attack? Well, all you have to do is press Z, and then you'll attack.
Okay, cool. Do I have any other attacks?
Well, for now you have just the one. If you open up the attack menu, you'll see all sorts of different attacks, but a lot of them are locked.
Oh, okay, so how do I unlock those attacks?
Well, first you have to level up.
Level up.
Yep. So if you look at the top left, there are two bars. The bigger green one is your health, while the smaller blue one is your EXP, and the number next to it is your level. The smaller blue one shows how close you are to the next level.
All right, and to get XP, I guess we can just kill some enemies.
Yep. I'm gonna go ahead and start and kill this enemy right here. So I'm gonna go ahead and attack him repeatedly. I'm doing 7 damage to him repeatedly, and he's gone. Now I have more attacks. So I can go ahead and drag and drop them into my moveset. So now pressing B still does the fireball attack. Oh, okay. Looks like something went wrong. I'm gonna go ahead and leave and rejoin real quick. Okay, let's try that again. I'll go ahead and kill this enemy right here. Okay, so I have new attacks. I'm gonna go ahead and drag and drop them into my moveset. So if I press X, I do the new attack that I just assigned to the second slot. And if I press C, I do another attack as well. So that's basically how the game works. Oh yeah, and once you press tab, you can see all of your stats. These will also increase as you level up. All right, I'm gonna go ahead and explore more of the map. Let's all go this way. I'll follow so through no Gary.
I'll try to split up and try to find the boss.
Okay. Oops. All right, I'll go this way. Looks like there's a lot of enemies over here.
Yeah, get those guys.
Yeah, I'll go ahead and fight them. Luckily, I have all sorts of attacks, and I can just keep them away from me. Okay, I've defeated one, and I've defeated the second one. Oh, looks like someone died. That's okay. All right, so it looks like I'm level 12 now. And look at that, I have a lot more attacks, and I believe my stats went up as well. I'll go ahead and drag some new attacks in my moveset. So now pressing X does this tornado attack that boosts me upwards, and it attacks enemies below me. Meanwhile, if I press C, I can charge at the enemy right here. Oh, well, I guess that wasn't a good idea. Looks like I died, but that's okay, because I respawned at the very start.
Oh, I died too, Eddie. But I found the bouncer over here to the right. Let's go that way.
Okay. I'm gonna go ahead and try to fight some more enemies. I believe there's one down here.
Get that guy first.
Okay. Well, looks like the boss door is right over this way. So I'm going to go ahead and go over here. And I'm just going to go ahead and rearrange my moveset one last time. Let's go ahead and have the attacks back. All right, let's go ahead and fight the boss. Oh. Well,
Well, it looks like he's gone. I got him already.
all right. Well, that's okay. So if you want to split, okay.
Yeah, so should we try again on it?
Yeah. Andy, how about you go ahead and set the room this time?
All right. I'll get one.
Let me go ahead and find room this time, and then I'll wait for Andy to make a room. Oh, it looks like he's made a room called Andy's Cool Room. I'm gonna go ahead and join it. All right. Well,
All right. Looks like everybody's here. I'm gonna go start it up.
sure. And this time I'll go ahead and play as Gary. All right, and then I'm going to hit select. And wow, it looks like a different map.
Yeah, there's all these new enemies are spawning in different systems and all the platforms are different.
Yeah, and every time you'll play the game, the map will be a different layout each time, and the boss will be in a different location. So it'll be a new experience each time. And because I'm playing as a new character, I'll unlock more attacks. I'll unlock different attacks to level up. Like these, for example. All right, and that's Wildlife Odyssey. Thanks for playing.
Question. It's question. In front of them.
Yeah, there's questions. Yeah, so, yeah, audience is welcome to, ask any questions. My first question is, did you have to get really good at the game in order to, present this demo?
The good thing about it is we can tailor the game and make it as easy as it is for how bad we are.
What were some of like the challenges that you faced, building this game?
I'd say definitely the networking, getting things to be synced across like all players. As you can see in the demo, it still wasn't like completely perfect. Like we still had a few issues getting things to work. Like in general, I think multiplayer, anything multiplayer related was like kind of like really hard, like for us as a team to like work with. But we tried our best, and I think we still got a pretty good like result at the end of the day. Anyone else want to answer that question?
Yeah, it was like any small change that has to deal with the networking would snowball into a bunch of other networking issues that always ended up taking a lot more time than expected to resolve.
Yeah, we also have like issues trying to find like which kind of framework we should use. Like Photon, and there was Mirror. We end up using Mirror for some things and then Photon for other things. And when you try to find a way to use both of them at the same time, there's kind of some confusion. Like the Mirror's Discord and talking to the people who created Mirror, even they were like, yeah, that's probably not a good idea. But it was kind of, we were kind of far into it. We already
What you know now, how hard do you think it would be to redo your network?
I personally think it's just the way we first approached it. We didn't think it would be impossible to do something like single player to multiplayer. Turns out it doesn't work that way. We should start with multiplayer aspects and then build on that to build a multiplayer game. So I don't think it would be as difficult. Again, we work backwards. We kind of have the procedural generation already working, the level generation already working. And then we kind of, we even had player spawn. But the problem was going from that to then backtracking this multiplayer was quite did that.
Are you guys using any game engines? Like I'm not familiar with Photon for like networking specifically. What do you
We use Unity. Photon was just it was a networking thing that we like that works with Unity.
See projects done in Unreal looks less like focused on programming and more with like distribution. I don't think I would want to use that. I think I'd still stick with Unity, but I mean I do have a grasp. It wasn't that friendly.
I think our biggest gripe with Unity was they had their own like GitHub equivalent for Unity projects, but it costs money and we didn't want to spend money. So we used GitHub to use on our project file for Unity, and it didn't really play nice with it. So we would have some merge conflicts every so often beyond like what you resolve in GitHub. It was, oh, it's just not pulling from GitHub properly sometimes. So that caused a lot of troubleshooting the first time that happened in the future.
Any issues with cross platforms?
In terms of building the project, yes. So building on Windows and Mac, Unity makes it very easy. But if you try to build for, say, Mac on a Windows machine, you get a different result than if you were to build a Mac project on the Mac. So, but luckily we had someone who uses the Mac. So.
Honestly, just authentication, having way to look in the future. We were gonna use that to build on for like save your level stuff, but right now there's really no difference. But
Did I hear probably that like stuff like the maps are generated differently every time?
Yeah, so, I mean, you want to know like the algorithmic details of it? Okay. So basically the way it starts out is with two grids of basically like one's the walls, and then one's going to be the rooms inside of it. And both of them are going to be completely popped. Then the one that represents the rooms that's slightly smaller, we give a random weight to each one of the walls in there. And then make a minimum spanning tree from that. And then any of the walls that intersect with that larger one get deleted. So that makes a maze. And then from that maze, we delete random other walls in that to like increase the openness of it. And then when we remove those walls, we also add them back to the minimum spanning tree. Anyways, that keeps track of all of the paths that are available. And then from that new graph of the rooms, we then do a breadth first search. And we find the 2 points that are furthest apart from each other on that graph. And then we start the players in one and we lost.
What's your favorite part?
When I was working on procedural generation, I didn't work on that necessarily, but I worked on taking the input from that, so I ended up becoming a matrix, and then figuring out how to spawn everything using food bags.
My favorite part was just making the new characters and. Okay, my favorite part was making new characters with different specific attacks. It was just like it just allowed me to, like just put my creative like endeavors to use and just find out like different ways for like the character to like interact with like different like attacks and like apply like different types of hitboxes and stuff like that.
I guess my favorite thing was just building the Indian UI, and with that, it was a lot of integration with other people's part of the code, which I enjoyed doing.
My favorite part, it's not directly working on the project, but I like just seeing it all come together and seeing everyone's faces as we dealt throughout the class, having it build over time.
I really liked when we were like switching between multiplayer solutions. We ended up having to host our own servers, and working with Docker and Docker Compose was pretty neat. Like being able to create Docker of our server.
The first time we got in, I think it was like a big shock for everyone, like how cool it was just actually, being able to use something.
Could you speak more to the sort of like how the back end is kind of generating those levels, and like because you said that you used Docker Compose, Linux, and how did that all connect together? I hate to put you on the spot, but it's really cool, and it kind of is that next level beyond just an average game project. So how did that go? How did that work?
Sure. Yeah. So Unity has or whatever platform you choose. I using DigitalOcean Linux server. So Linux. From there, you you have to do all the setup for Docker Compose, and then the Docker Compose file allows you to say create rooms, and then based off of that, you can map ports. So for in the lobby, I was able to set a random port for everybody, and then send that through to the game, where they're able to all set their ports to the same room. So it was basically right now we just have like a predefined list of like 15. It's port 7777 through 7791 or something. And each one of those is a port mapped to our server.
That is awesome. Is the generation code still in MATLAB?
Yeah, so the level generator, when I originally wrote it, just as like a prototype, I wrote it in MATLAB, because MATLAB has all the data structures I everything Unity uses has to be in C#, and I could not find any like, decent graph theory packages or libraries or anything. in C#. So what I ended up doing was once I got all the MATLAB code working, I used the MATLAB runtime, which can run MATLAB code on basically anything that installed runtime on. And I put that in a Docker container. So there's a Docker container running MATLAB runtime that's running the world generator. And that's all existing in Oracle Cloud running on a small virtual machine there. So there's this very small microservice that's just hanging out on the internet that all it does is just generate maps for
Wow, how cool is that? Like, alright, any other questions?
Yeah, whose original pitch was it, like, for the game, and then, like, how close did, the game get to?
So it was my original pitch. I will say I did have like bigger like ideas for like all sorts of mechanics, like new characters and like different enemies. And if I were to like work on this game, like do nothing but work on this game for like the entire semester, maybe I could have like gotten all of it done. But it did end up like not being like as much as I like was like planning to have integrated. But I think that's okay because what we have is still like really cool. And I am like still proud of the work that we managed to get done. And like I think that this was just like what we did manage to get done was like what we did manage to get done was really cool.
Your plans were a great question.
Maybe.
Any last questions? Because we do need to move to the next group.
Just quick questions, who designed, like, the art?
That was me.
Everything will
Thanks.
be.
Yeah. I just made them like in my free time.
Alright, well, any last burning questions?
I think we're good.
Amazing job, guys. As the camera said,
Oh,
focus
we don't
back
need
on
it.
you again.
Yeah, you're gonna just be screen sharing or whatever, so.
On.
Oh, wait, let me. Close my email. Or let me go ahead and sit down.
I would like stand.
You wanna stand?
Yeah.
Alright, cool. You wanna move this out?
Just move it out.
Yeah, press the share button. So. There you go. Yeah, I'm gonna be honest right after this. Like, you know. Yep.
Give it up to our PhillyGPT.
All right. All right. Hello, everyone. My name is Ali Shahid, and today I'm going to be presenting our capstone project, PhillyGPT. This project and the whole capstone course is the culmination of our time here at Temple University, and I'd like to thank our professor, Professor Applebaum, and our TA Tan for all the support over the course of this semester. And before we get started, I'd like for all my team members to just introduce themselves.
Yeah, so my name is Prince. Good to meet you all.
Hello, my name's Aiden. I'm Andrew.
All right, so let's get started. Our city pretty much has this thing. It's called the Open Data. It's called Open Data Philly. It's a resource just filled with data sets. Just about information about Philadelphia. And the only thing is that the average person, they would probably have trouble accessing this. It has thousands of data sets, and they're all in large CSV files. So most people, they're not gonna, use SQL to query through them. So we decided to create PhillyGPT and make the data more accessible. So pretty much what we did is we created this interface, and what the user can do is they type in a question, and then using OpenAI's GPT 3.5 API, the question, it gets converted into a SQL query. And we are hosting several databases on an AWS MySQL server. And from there, the OpenAI generated queries, they get executed, and it pretty much gets returned in an easy format. So, Prince, you want to get started and share what we created?
Yeah, so basically, I'm going to show you some example questions that we can ask our application. So we have some prompts that we can try out, but then also like a dynamic search bar that we can use. And for some questions, this map of Philadelphia will actually be used to add some extra context to a user query. So let's just get started. Since we're in Temple University, the first prompt that I will ask PhillyGPT is, can you give me the buildings related to Temple University? So okay, well, sometimes at demo time, okay,
You know, the back end.
everything should be running, but it might be that my computer is having some issues. Second. So yeah, just had an issue. Had to restart the servers. The servers were down and probably close to my computer. Things went wrong. So I'm going to start again with the first prompt. Can you give me buildings related to Temple University? Search. And then here, basically, we get a response in table format that gives us extra information about the buildings. And then we also see the SQL query that was used to query the database. So people who know SQL better can basically double check and make sure that the response is correct. And then here we have this map feature here. So we're basically able to see like all the locations of the buildings in this map, and also gain some extra information from them. So let's say I go over here and I see a marker that seems to be outside of Temple University for some reason. I can click on it and it tells me located at 2450 West Hunting Park Avenue. This building related to Temple University is a versatile office and commercial space with parking. And then it keeps going on and gives us some extra background information. And yeah. So basically, yeah, that's where the human resources office of Temple is. I was going to show you on Google Maps to kind of show you this data is real, but I guess Dr. Kwatney just confirmed that for us. So we're going to skip that part of the demo. So thank you very much. We'll just hop right into the second prompt from here. So we want to query about crime in Philadelphia. That's something that's pretty important. So we want to ask what the number of people arrested for aggravated assault is. And let's say we want to have that in the time range of the year of 2023. So I can go back here and I can ask PhillyGPT the question. Just going to give us the total number of people. And there's no map associated with that query because that's not what we're asking for here. Then the next prompt that I want to show you guys is how many citizens under the age of 24 are vaccinated. And this is all just data related to Philly. And then it's going to give us another response with the number of people under the age of 24 that are vaccinated in Philadelphia up until this point. And then we have the SQL query that kind of shows how we found the data. The next question you want to ask is, which 10 parks have the largest area? Search. And then here we get the name of the park and the associated acreages. And it's 10. So yeah. And for the final prompt, we want to show up the map again. So let's say we want to get information about Independence Hall or some other important Philadelphia landmark. Then we can ask, give information about Independence Hall. Quick search. Takes a bit. And then here we get some information in our response. But the cool thing is when we scroll on the map, then we can click basically on Independence Hall. And then we're going to get some information related to Independence Hall that kind of tells us more about it. So I'm just going to give you some time to read, but maybe for the people in the back who can't see what it says Independence Hall, situated at Chestnut Street, is a historic landmark within Independence National Historical Park. This iconic building, designated as a museum, holds significance as the birthplace of the United States. And it goes on, gives some extra background information. So now I hope everybody has a good idea of what PhillyGPT does. And there's some things that I kind of wanted to address that are more, I guess, on the technical level. So obviously we're using a lot of like databases in our backend, and we query them with SQL statements. So what some of our classmates have brought up is that our application is very susceptible to like SQL like injection attacks. So what happens if we instruct PhillyGPT to drop a table, for example? So when I, let's say, right, drop city landmarks table, and I search, then what I'll get is I get like go to like a read prompt page, and it's not going to tell us we did something illegal. It's just going to tell us you can't find what you're looking for, and here's some suggestions to improve your prompt or some alternate prompts that you can use. And then here we have the example, find information about Philadelphia city landmarks. So yeah, I think that's like the main part of our demo. I'm going to open it up to some questions. We're all happy to talk about more about the features and how we implemented them. So yeah, do that. Let's go with that first and then see.
Could you like explain a little bit of the process that you use for like, prompt engineering?
Yeah. So essentially for when we get a user input, we're gonna be prompting twice. Currently, we have about, I think, 9 tables in the database. We wanted to get more, but we just wanted to make sure that these timetables worked. And at first, we were having a long prompt with like the whole column, table headers, and that was an issue with like tokening. So we resorted to chain prompting, which is essentially the first prompt, we're going to be determining the proper table, what table is associated with user input. Once we get the proper table, we can we're only passing the associated headers. That way we're not passing the entire schema to ChatGPT. And that second prompt is getting the SQL query. If the SQL query is valid and we get a response from our database, we would return it. If that SQL query has any forms of SQL injection, drop, truncate, insert, delete, we're going to pass that error and go to the prompt page.
The website looks very great to me. Do you have any way to fix that?
Oh yeah. So we can switch on dark mode.
With the example.
Oh, those were just some use cases that we thought would be like cool to show off so that people kind of know what they can ask for. Yeah. So some
Yeah,
information.
so it's the example question, farmers markets, get some data. It's a good basis to start on if you don't know what to ask. Go in the back.
Were you guys actually susceptible to SQL attacks before trying to cover it, or was you just really trying to?
Not exactly, but in class, the issue that get brought up, so we decided just to protect from like malicious actors, we would implement that because the databases are an important part of the whole project. So if they get dropped, then everything is gone and it's not going to work properly. Right there in the back.
Do you know, say, in your research, do you know any other cities kind of have a similar thing where they have these cities, this open data, that you realize they could potentially allow this for other cities?
So we did find this project. It was called San Francisco GPT that is pretty similar. But the only problem is I think they had it running for about maybe like 3 months before they just turned it off because we're using OpenAI's APIs and that does get expensive or whatever. So yeah, the project's pretty much dead, but we revitalized this for Philly. And their project is only related to San Francisco. So yeah, we thought it'd be nice to have something for Philly. Sean?
Okay, I'll go. So yes, it took a lot of refining of the prompt to get it right. We also have some like reprompting mechanisms there that kind of help the user or help us go into the right direction. But oftentimes, or not oftentimes, but sometimes, yes, things just go wrong. And then we just have to basically start anew. Oh, I think Jacob's Nar went first, actually. Yeah. It's actually yeah.
Oh, you want to go? Okay. I just want to say I think we would probably add a lot more databases. So in the whole Open Data Philly program, there's like I said, there's thousands of data sets. I think we would implement more. Also, I think something that was a lot like just time intensive was cleaning some of these data sets. I think you might have noticed when we asked one of the questions, nothing really showed up on the map. That's because we also data sets they don't have like coordinates and stuff like that to properly work with our project. So I think a lot of more just adding more data, I think would make it better and more all encompassing.
Yeah.
Do you have anything to add?
I guess for the map, we would like to have different types of maps. So the markers work well for many use cases, but sometimes maybe a heat map would be more suitable, or maybe even not a map, maybe a bar chart or something like that, where we have a little bit more like dynamic responses. Yeah. So I think going.
So you said that the databases were in CSV files. So how do you change what's underneath if it's some other type of data structure? Can you take your application and put it on a different set of data structures, tables?
Right. Well, at that point, what we did is we just manually converted those CSV files into like a MySQL database. I'm not 100% sure.
So what I'm asking is, what if you don't have CSV files? Have something else build an interface that's a little bit more
That would be possible. In our case, since we only relied on Open Data Philly, we just relied on the CSV files because they had CSV files for every single database that we wanted to use. But let's say if we had another source, maybe we wanted to build for San Francisco or multiple cities, and then we have to pull from multiple different types of files of multiple different types of databases, then I guess you would have to look into building like a proper infrastructure for that. But at this point, we kind of could get away with our current approach. Exactly.
Might be a good spot for an API.
Yeah.
Why not just read the data, read all these?
That is absolutely true. Yeah. In our app, we also have like some scripts running that basically update the tables for some like longitude latitude data. Obviously we could have written our code base in a way where it's like whenever we use some kind of like key or some kind of like password, some authentication to update the tables, that then the database knows, oh, it's all good. But how we did it and how we just built from the ground up, right now the best case for us to go about it was just checking whether there were like malicious statements in the SQL. But thank you for bringing that up. Oh, did Neil still want to go?
Jacob asked.
Okay. Yeah.
When users asking these questions, any capturing of the results so that you could, I don't know, optimize on that. So like if 20 people are asking one specific question, that you could return it sort of in terms of relevance, to maybe bring that forward in a more obvious way. So like when you had your examples there,
Yeah.
could you bring your examples, you know, you make, I guess I'd say you make this examples relevant, based on, I don't know, trend of questions being asked.
Oh yes, that would definitely be possible. We would just like basically cache the questions that were asked and maybe we could ask ChatGPT or OpenAI to basically categorize like the questions to different like buckets or something like that, and then be able to show like very popular questions related to like a specific category. But we didn't implement that for this project. Yeah.
If the data sets, were you looking at data sets where they all basically similar, relatively the same fields, or were you having to deal with dynamic structure for your table plus based on the nature of the data that was pulled? So in other words, if you were talking about vaccines or whatever, I mean, obviously you didn't have location data for the map, but were you expecting, like, do you use common structure and just leave that empty, or what was the thinking around that?
There was no common structures. We just all the tables had like very descriptive like table headers. So actually we kind of used GPT to help us there again, because there were some maps where we did not have location data, but they could have used location data. So we checked for like headers like address or like other like keywords that were kind of similar to that. And then once we were able to extract that, we wrote a script that basically updates all the table with like extra location data and things like that. Yeah. So there were just some like rows in our table that were just lacking information for some reason, and that could like break like our app, because for example on our map we might have issues displaying the markers because like some of the data is corrupted. So we had like another script that kind of like went through and made sure that all the data that we can use is clean for showing on the maps. Yeah. Thank you. Anybody else? Yeah.
How much do you cost per?
You can go more.
So pretty much for all the hosting on AWS, I'm just using my like free tier account. So that takes care of most of that. For the OpenAI API, it's mostly just pennies. It's pretty cheap. It's really not that expensive. We're using the 3.5 Turbo API. So yeah, it's not really that much.
One of the most expensive parts was actually updating the tables with longitude, latitude data, because we kept having to make requests to like Google Places API to basically convert an address into like coordinates. And since we have like thousands and thousands of rows, that like racks up costs. Yeah.
You anticipate them to next month?
Yes, as long as they provide an API, that's no problem.
What was the biggest challenge with using GPT? I can't remember if that question was already asked or not, but I know that a lot of students will either question like, oh, how is this project is just calling the GPT API, or it'll be like, you know, I want to use GPT in my next project. Is it a feasible thing? What, like, how would you respond to either of those two things? What was challenging for the most challenging?
I think we went through, I know we went through one idea before going with like the chained prompting. We were looking at like keyword buckets. That was just way too complicated, at least for me, and I couldn't figure it out. But once we did land on chaining the prompts, weighing tokenization versus efficient output was probably the most challenging. Like I said, we landed on passing only the schema that was necessary for the user prompt through determining the table first. If we weren't to do that and maybe we were to try to cut down even more, you start seeing like major inefficiencies in the result. Good question back.
What was like your most favorite challenge to overcome? Like just maybe something that you stuck on for a couple of weeks?
No princes, but probably the map.
Yeah.
I worked a lot on the prompt engineering, so I think figuring out that concept that I just explained, how that was going to be set up and determining the table and stuff like that, it felt nice once I started getting like valid equal statements sent and valid responses that were coming back.
I know you guys have went through some changes throughout this project. Like Marcel's API, you guys proposed a very big API connected project, as I remember. So if you guys can start all over again, do you guys do extra planning, or what would you guys change the approach?
Okay, so from my perspective, I think that we should have done is think a little bit more like research right from the start. I think we found like a feasible solution pretty quickly, but we kind of jumped right into it without optimizing. And I think as we started working on the project, we noticed that it would just be very over-engineered. So we had to kind of take a step back and then go a different way.
Against that, but I was wondering, like, could you make the attacker make like a prompt that like make like a inefficient SQL query that like made it time consuming, like is there like a limit to like how much time a SQL query takes?
That could be feasible. So we would definitely be kind of open to denial of service attacks at this point. Something that we would implement to stop this is you would make like user accounts for this app and then basically rate limit users, or we could also decide that the users would actually have to provide some like API keys themselves, but we didn't end up deciding on what to do for that. But thanks for bringing that up. Any more questions?
Well, it was a really great demo,
Thank you.
guys.
Thank you.
It's really the tracking's doing so well. All right, we got one last demo for you. It's last pad, and it looks like they're making their way up right now. I'll let them take it away.
Just like 5 minutes.
I feel like the mute feature is not working. Where it's
Like
just
they
like,
can
Yeah. Yeah. Oh, that's good. Yeah.
On your phone, right?
They do.
it's like a
Oh, you joined the group? No. It's really glaring.
So the thing I want is I want this camera to not be shown. Can we?
Yeah, if you go to settings right here. And
Okay, sweet. So now we just have, you can just drag this left and right. You can, let me, so you'd have to click this. And then just whenever we want to show this,
okay.
it's like this. And then whenever we want to show the editor, it's like that. So.
All right.
And then whenever we want to show both, you should try to just like use your intuition, like what we're talking about at that current moment and what would look the best.
Right.
And if one of us says like, oh, Jeffin, can you like focus on, oops. Oh, he wasn't sharing. Okay. Don't stop sharing ever.
Yeah, don't stop sharing, you break it. Oh, so this code editor side and it's just blast pad.
Yeah, exactly. This is code editor. This is the blast pad screen. So it's like whoop, whoop. Okay, cool.
So let me start.
When you share the screen, that takes like a full display.
Yes.
Whatever's on the camera becomes smaller.
So we're gonna
So
have
you
someone
may-
managing the.
Oh, you got Discord?
No.
We're gonna have somebody.
This is the editor on the left.
So
Really?
you may, yes, you might want to like either switch it off periodically.
Can we disregard them?
It'll be switched
What?
up.
Can we disregard them? How many people are there?
And I want-
I'll just try to-
Yeah.
Okay, cool.
Yeah.
You can do that.
You guys will get the better view that where you'll be able to see both.
Okay. No, when you switch it off, it gets switched off here too. Wait, what? That's like
Yeah.
it gets switched.
Yeah, that was the point.
Yeah, if we have someone.
Okay. All right.
So you just gonna like switch screens. I don't think so. Just make sure it's right. And stuff.
Moment here. You guys can grab pizza. I'm itching for some right now, so.
Then live into like. Yeah. And share Discord.
Okay. Yeah.
We all good?
No, yeah, no, if you want to do the split screen thing, maybe use Discord. Just have two, like the one live and the other.
I think we'll be.
Okay.
Yeah, we'll try. Yeah.
Great, good afternoon, everybody. Thank you all for attending. Today we'll be presenting our progress across the semester on this awesome project we call BlastPad. Before we get into the BlastPad though, I want to thank Mr. Applebaum. I want to thank Senior Applebaum for printing our case last minute. And I just want to thank all of you guys for attending, giving us feedback on the project for this semester. Give yourself a round of applause. And allow me to introduce everybody. I'll let everybody introduce themselves. I'm Snar.
I'm Mustafa W. My name is Jeff and John Cuddy.
I'm Niaz.
I'm Neil.
I'm also Mustafa.
And we are Team BlastPad. So let's jump right in. Let me show you around the BlastPad and see what's on the device. As you can see right up there, we have this device with this beautiful screen and a Raspberry Pi running underneath it. I'm just going to walk you guys through the UI really quick. So right here we have the home screen, and this is where any downloaded or created games would show up. Because this is a handheld educational device where we will allow people to create, play, and share their own games. So we will have games show up on the home screen right here. You will be able to create and edit on the fly, and then you'll be able to play them and share them with your friends. And so next up, we have a community hub. This is where any games that other people created would make, and they can share them. and you can edit them yourself and learn from them and see what other people have created and try to figure out how they coded it. We have a classrooms page, so you can share games privately with a group of people. And the host has spotlighted your video. Awesome. And so we'll get into that in a moment. And then we have a settings page with Wi-Fi controls, classroom joining options, login. Let me show you here. And then themes. We made our own Applebaum theme. It's yellow, since you love the color yellow. Then we have a couple other cool themes here. One for our TA Don, who helped us out a lot during the semester. Thank you, Don. And then a couple others to choose from. All right, so let's jump right in and see how we create games on the blast pad. I think that's really interesting because we use a block-based code editor for that. And that way kids can have a fun time creating games, stitching blocks together in a programming language type setup. And it's really powerful. So let's get into that, Neil.
Sure thing. Let me share my screen. All right, I was watching my DVD logo. One of the things I love about the BlastPad is that when I want to make a game, I can do it through my editor, through my browser. So this is where the games that are stored on the BlastPad will show up. Let's create a new one. This is our starting example project. I think for the sake of demonstration, I'm going to have my little mascot here. Let's make him green. I just want him to respond to the buttons on the blast pad. So if he moves left, let's say he moves a little bit to the left, move right, a little bit to the right, and off to the side, I'm going to put some responses to up and down. Here we go. So I have to give it a name. Say, yeah. Okay. The block editor runs through a couple stages where it tries to catch errors and tell you if there's anything wrong with your program. I don't think I did anything wrong here, so it should be okay. There we go. Looks good. If I hit the run game button right now, this will, since it's connected to the blast pad, show up on the SNARS blast pad. I'm going to hit this and then just stop sharing so you can see the blast pad. There we go.
Nice. Oh man, I can move around left and right just like you added there. And then those other blocks you added up and down, those haven't been added to the code yet. So let's say I want to make a last minute change really quick. I want to add those to the code base. I can do that right on the blast pad, accessing the same editor and the same code underlying the game in the other screen. So I'm just going to go on the blast pad here. It does feature a touchscreen, so it's pretty easy to move around this editor here. I'm just going to drag those blocks that Neil just created into my game, and then I'm going to save it. It's going to run through the same exact steps that Neil just went through, the compilation stage, error detection stage, and once that's successful, I'm going to click the run button, and it's going to run right over top of the code editor here, right on the blast pad. And now I have up and down movement controls as well. So on the fly game editing, this would work obviously without Neil's laptop. If we were on the go and I wanted to make an edit that my friend suggested, maybe in class or something, if we weren't paying attention, we could do that right here. So that's awesome. But what happens if we want to get a taste of what other people have made? What happens if we don't really know where to go from here, how to make a better game? What can we do to fix it?
That's a great question, Jacob. I'd love to show you all the Community Hub. The Community Hub is a collection of games that users can download, and they can also upload their own games. So let's start by showing some of the features on this page. So we have a search bar that users can filter if they want to search for a specific game that they don't see right away. There's also a refresh button right here on the right side. That's just if, let's say my friend uploaded a game to the Community Hub, I wasn't able to see it, I can just hit the refresh button, it'll reload the content on the page, and then I'll be able to see that game. So I think what we should do now is look through some of these games and find something fun to play. We have Golf by Neil. Seems interesting. Let's look at some of the other options. We have Wildlife Odyssey by Alex McGinn, very interesting. They got a hold of a blast pad and they were able to recreate their game on the blast pad.
It's great to see other blast padders out in the world.
We already saw their games, and that would be a little redundant if we just played that same game again. Let's go to the next game, see what that one's like. We have a block dude made by myself. Very nice. Sort of description. Classic game made for Texas Instruments graphing calculator. Get to the door to win. You know, that sounds great. Let's try to download it and see if we can play it. Wow, beautiful download screen. Go back to the home page and let's just run it and see what happens. So another neat thing about the blast pad is that you don't necessarily have to use these controls. You can also use a peripheral device. We have a keyboard plugged in right now, so I'll be showing that off and using the keyboard. We have some instructions for the game. I made the game, so I already know how to play it. So let's progress to the next page by pressing A. And let me just explain how this game works. You can move to the right by pressing right. You move to the left by pressing left. You can climb blocks. Very nice. You can pick up a block, put it down with your down arrow key, and you can also move around with the block. So the goal is to get to the door that you see on the right side. And another thing about block dude is that you can soft block yourself. So here I can't pick up this block because there's another block on top of it, and I can't climb up because I can only climb height of one. So I'm stuck here. I'm going to do now, but the game developer was so generous to think of this, and you can simply restart the level by pressing
The game developer.
Genuinely flabbergasted.
the door now and not soft block ourselves. Should be a simple enough solution. Just take a little staircase and climb up to the door. And then it brought us to a new level. Now you might be thinking multiple levels. That's insane. Like, you must have taken him forever to do this because like he would have had to place all these environment blocks manually, all these boxes, place them manually. But actually it was very simple because of the nice feature in the editor called bitmap iteration. Let me show you what I mean. Neil, can you pull up the editor and open block view?
Yeah, absolutely. So now that we have block view downloaded onto our blast pad, you can check it out on our computer. So we got our demo game and block view showing up. Let's edit block view. Gosh, this looks very complicated in your stuff.
Let's just zoom out and maybe I can, if Jeff and you could scroll to the right so you can see the editor. Yeah. You just zoom out and I'll just run you guys through what this is. Collision logic. We're interested in this array right here of bitmaps. These are, if we go to the top one, we can see that was the first level. The boxes are in the same position, everything looks great. And it just iterates through this list. And that's how you progress through the levels. And it's very simple.
Jesus, that's what looks hard.
You know, I just realized this is going to take me forever to play through all these games. So how about we modify this list? How about we drag this list out, Neil?
Oh yeah, okay.
Drag this. Oh no, drag the entire list out.
Entire list? All right.
Yeah. Let's make a new list that only has one item in it, so that we can just only put one level in there, and we only have to play one level to finish the game.
Wow. You know what? That sounds like a good idea. I'm gonna go with the first because.
Oh, that's too easy. Let's go with like the last level. Something we haven't seen yet.
The final.
All right, man. As long as you're playing it.
Yeah.
I have not beaten that last level just yet.
Oh, well, you might have to close your eyes because these are going to be spoilers. Right?
Okay. Yeah, I don't want spoilers.
All right, so I'm going to save the game. Let's you can run it from your editor on the laptop as well.
I kind of want to see that fun playing game.
Oh,
loading
yeah,
splash.
I have as
Give
well.
us that for saves. It's a really big project. There you go. That's it.
Sweet. So Jeff, and if you could just go ahead and.
Oh, let me stop.
Okay. Yes, let's go ahead and play it. See our solution.
Practice this a little bit.
Yeah, pretty good.
like so much. I'm totally sold on the community hub. You think I can buy games, that little demo game that we made up there?
You know what, let's try it. So you want me to share your game to the community hub, right?
Yes, please.
Okay, let's do it. Share demo to the community.
So does that mean other people are gonna be able to see my game that I made now?
I believe so. There it is.
Whoa, that's awesome.
That easy.
Yeah. So let's try to pick another game to play now. Niaz, what's your favorite game?
My favorite game, you actually can't find in a community hub. It's in Professor Applebaum's classroom. Mentioned before, classroom is a private collection of games. So we take a look at the classroom. Oh, we're not in a classroom, right? So let's sign in. Oh, Professor Applebaum, what's the invite code to your classroom? Don't worry. Don't worry, I will never forget your. Just- All right, we're in a classroom now, so if we go back to the classroom page, see some games. And this is the game I made with Breaker. So let's just download that to the device.
Oh, there's maybe one more other game we should show off that's enough. There might be one game in there.
Oh, your favorite game. Download this game. We should be able to play it locally on our very own laptop device. And there we are. Just play.
This is a classic. I don't know if you guys have ever seen anything like this.
Feeling for this.
Oh, man.
But, oh, I can always restart.
Where's the quarter slot on the class?
Yeah, we're hitting microtransactions.
So I love the classroom, but I noticed my game wasn't on there. I want to put that demo game on Applebaum's classroom.
Oh, well, we can easily do that. Now that we're signed into a classroom, all we have to do is hit the share button, and there we are. We can share it to the classroom.
Yes. And all my friends are gonna be able to play my awesome demo game.
All right, now if we head over to the classroom page. There we are, the example. The example game you just made is now on your class, is on Professor Applebaum's classroom.
Awesome.
So what if I graduate and I no longer want to be in Professor Applebaum's class? Can I leave the classroom and join a different one?
Yeah, so that's actually pretty simple. We go back to the classroom page, we have an option to leave the classroom. So as we graduate Professor Applebaum, unfortunately, we're gonna have to leave you.
I downloaded multiplayer Tetris though, so I can take it with me.
Oh,
Don't worry about it.
Thank you. Yeah, that's an awesome feature. So the classroom feature is something we're really excited to add, and we can see it being used for teachers to share their learning exercises, example code, and all that with their students privately. So that's just an awesome feature that you demonstrate. And that's about all we had to show for today. We're again very proud of the Black Pad and very thankful that you guys all showed up. Do you guys have any questions for? You want to say the line?
I want to play a certain nice game in the next.
Yeah, why don't you do that? Yeah, why don't you set it up while we.
So if I were, let's see, maybe, and I uploaded that game to two instances of the game now.
Great question. Right now, how the community hub works is you can only have a game of one name. You can only have one name per game. So you would overwrite a new version of your game, but you can easily change the name and upload it as your own. And you can also steal Neil's code if you want. Okay. Yeah, this code if you want. Question?
So like for entering codes and logging in and stuff, I saw that you guys are like using the attached keyboard. Is there a way to log in?
Great question. We do have an on-screen keyboard package, but it's a little finicky right now, so we didn't want to use it for the demo. But there are a couple on-screen keyboard packages we added that do work with the touchscreen and all. Keyboard just for this demo and better screen real estate. That's a design thing that we might need to change in the future.
First off, in terms of like the current market for something like this, do you feel like it has its own place? I think I remember you mentioning where other talks or during proposal, there's the micro bit. I find it a little lackluster when it comes to for the flight, basically. Do you think this kind of would be a work something like that?
Good question. Yeah. So when I had the idea for this project, I looked at a couple of the competitors. I used to be a tutor and I used to work with tools like this. So I wanted to create a better tool. And a couple of the features that made the blast pad stand out over, say, like the microbit. One is it's more powerful. It's based on a Raspberry Pi 4 computer, which can run really, intense games. It can do PS2 emulation and all of that. So I figured that would be way better than, I don't have a photo of it here, but the microbit just is like a little Arduino device that has 5x5 LED screen, so like literally 25 pixels total. So I thought this would be way more powerful than that. And then there were a couple other features that I thought would make it stand out, like the wireless capabilities that the microbit doesn't have. So editing a game on Neil's laptop without having to plug into the device is a really cool pro. I could see that being used on like iPhone maybe, like an iPad if you wanted to edit games. And then just the colorful screen, like I mentioned, TikTok generation. So they want to see big break things. They want to see beautiful videos. We can keep my students engaged. While this, all the code compiles down to Python from our Blockly like JSON version of it, and this lets kids grow with the device. Like you can grow with Python and make really complex games that you saw there, or you can make simple demo games and just drag. Good question.
First things first, you guys have a really good UI. So I'm talking about how you made your UI seems to really fit the screen.
Good question. So in terms of the cutoffs, I just want to start with that because that's something we got fixed very recently. There were just a lot of like low level like packages that we had to use and like programs we had to use to set this up. One of which was a Chromium browser, like Chrome browser, but without any like bars at the top. So this is all web UI. So we just had to like put little command line arguments in there to get the screen position right and the sizing just right. So take the full screen. That was a little tricky to figure out. There was some great documentation on that. And then the UI itself, we built with React. We built reusable components to try to use throughout the UI and try to mock it up early on in Figma. And we mocked up almost everything in Figma before we actually created it. So we could get a feel for what the UI would look like, prototype it, see how users used it and all of that. Oh, we also started out using a Python library called Tkinch, because at first it kind of seemed a little weird to create like an embedded system device with a web UI. Seemed a little out of sorts. So we tried a lower level library called Tkinch that works with Python, and it's a graphical library for creating user interfaces. And about a month ago, we took a hard look at the code and we were like, this isn't like going to be demo. This isn't going to be like successful, and it's going to be a lot of especially we had to implement our own UI architecture called an MVC pattern, and it was just a lot for us. So we pivoted to React later on, rebuilt the entire app in like one weekend in React, and it was smooth sailing. Question?
I think this is one of the cases too, where they started with like the Figma prototype and they really iterated on that early on, and they kind of just really kept like firmly to that design. So it's like, if you look at their early Figmas, it looks like this. They made changes to tweak for the different like styles of how it was going to be handheld and things, but really they stayed close. Really cool to see. One question I have.
Okay.
How do you map the because I think like we're watching all these blocks being moved around, right? And we're just assuming that that is the programming language, but actually there's another layer underneath. How did you guys get that all working?
Neil could answer.
Oh man. A lot of hours, a lot of time. It's a multi-stage process. So we built our block editor off of Google Blockly. Now, Blockly supports it's actually a really nice like kind of TypeScript ES6 web framework where you can drag blocks around, and then there's it allows you to write definitions for how those blocks translate into code. Kind of allows you to control whether they will be interpreted as variables or like ordered functions, all kinds of stuff, scope, all that. But it really wasn't powerful enough for us. So it began this like maddening deep dive into trying really hard to extend and break and just wrench every bit of power out of this kind of dead open source tool. Eventually we got it figured out. So behind the scenes, there are a ton of custom blocks, which all have their own Python definitions. We're using a lot of tricks. We're doing a lot to make sure that the Python compiled is valid, such as, I think there's a compile step where just at the very top of the generated Python, we add all the headers, like we import Pygame, we do all that, we create helper classes for all kinds of stuff. These bitmaps are bit fields. So these have to be just smacked in there as a really big list of 2D arrays if we actually want to use the data inside them. But we also have to save them as images, so Pygame can render them as sprites. So there's a lot of moving parts. It's actually a miracle that it all works, and it works very well. The error catching was a really big part of, really big help in trying to figure out like what was going on. So I can force an error here, and you might be able to see what I'm talking about. It actually tries to run your game in the background, beyond just checking to see if it compiles all your images, save all the blocks have valid fields and everything. Very small error, but there are a ton of cases. So this one just says my game didn't run, probably because I had, I don't even know what I deleted, but I deleted something bad and I didn't like it. Really complicated, a lot of moving parts. Honestly, a miracle that it works. One of my favorite parts of the project.
You have an estimate of how many like actual
Oh, how about the last week? What do we think last week?
In the last week, like maybe at least like more like 50 total. Yeah, it's been a lot. We had to put a lot of time into this project with the hardware, software. There's a web server underneath applying the UI code and the Blockly code to both this device and the laptop. So we had a whole sprint where we were working, some of our team was working on getting a Wi-Fi code set up in the background. So this could communicate with the Linux operating system and get Wi-Fi running. So we put a lot of hours into it.
Beyond that, we had to scrap all the Tkinter code.
We scrapped all of it.
All had to be
Other questions?
Yeah, can you talk more about like the stack and the things that we don't see that are happening here? Like I just remember that you guys have like the edit through the web app and then also just on the thing, right? So like there's a lot of stuff I feel like that we're not seeing here.
Yeah. Yeah.
So we have a couple components. One, I think most of what you're seeing is a Flask server. So the Flask server is our go-between for the classrooms, for the community hub, all that. It is in charge of starting games. So we have an endpoint that says run game, which starts a compiler, starts the Python, switches focus, does all that stuff. That's all handled by the Flask server. Same for saving and the Wi-Fi stuff, that's all also on Flask. The front end is compiled JavaScript, so it's a Webpack. We build bundled JavaScript and HTML. Our block editor is just, I think it's Blockly just wants to use Webpack. It's not using React or anything fancy. It's just compiled JavaScript. This home screen and all of the UI here you see is Byte, I believe.
Beat runtime, React components, stuff.
Yep. There's a node dependency. The compiler. Yes. Yeah. And then beyond that, there's a node dependency for running the compiler, since I wrote that all in JavaScript. So
we have super big Supabase, running our classroom server and all that. And the reason we went with that is because Supabase is like a software as a service database solution that provides you authentication API endpoints and database API endpoints, storage bucket API endpoints all put together. So that allowed us to have a server that we had to manage ourselves. It just does that to make it store everything we need.
Have you used Firebase before?
I have.
Okay, so with experience of both platforms, like,
I like Supabase a lot better. You guys know
I like Superbase a lot.
Supabase is everything's a lot more tied together. Feels a lot easier to integrate. Somewhat, yeah. But all their library support all tech stack. And then also it allows you to run it open source, so you can run it on your own if you want, so you don't have to keep it tied.
You can send this out as a fully fleshed out. In that case, you guys.
I'd definitely say figure out the keyboard thing. I would say some case revisions would be necessary. We wanted to add sensors to this as well. We never got around to that, but we wanted to add sensors to this so that way, let me actually show you here. You could like add blocks to your game that would change based on sensor inputs. So just to make it a more fully fleshed out product and more competitive with the microbit. And maybe even right now it's just like mini breadboard PCBs that are soldered together, but a custom printed circuit board would have been. It's something I planned on, but shipping times should be trying to build up that.
Look at the curtain of Oz.
Question?
Yeah, I had a follow-up question. Want to add in some sort of feature so that like you have like a teacher in the classroom.
Yeah, definitely. That was part of our plan, right?
Yeah, that was part of our original design. Kind of around the time where we scrapped all the Tkinter code, we were like, oh, we don't have time to do that anymore because we have to redo all the UI. So that's kind of what got shoved out. There were some vestigial components of that. Like we do have profiles, and you can log in, you can make an account, you can do whatever. It just doesn't do anything. That's where that teacher functionality would kind of come from. Tkinter started off, it means we didn't get to do that. Yes. Oh yeah,
Absolutely.
yeah, absolutely. Yeah. I did that many times. Yes.
Yeah.
Yeah, absolutely. It's local host.
Yeah.
So yeah. So the reason we have the Flash server running on here, so that if I'm on the same network, is I can just go to blastpad.local and just access the editor on here.
Yeah. I want to make this one correction. You do need Wi-Fi, like an access point, to share that with the laptop. This doesn't have an access point on it. But if you have like a hotspot on your phone, or you just want to, what? It has Ethernet. Yeah, you can connect from Ethernet. You can access that port on the side there, or you can edit it on the screen.
Yeah.
But a Wi-Fi access point would be integral for the wireless editing.
Project is pretty fast
Yeah.
and hot. This achieve your proposal?
Yeah, I would say this achieves my proposal. Yeah. Like the sensor thing was like one thing that I really wanted to add. Besides that, I think did it pretty
You mentioned that you did a lot to improve the block editor. You want to talk about when you showcase any examples of what those improvements came out as?
Great question.
That is a great question. It's a lot. It's more code than anything. So the goal was to make games easy to make. I am genuinely shocked that it's as easy to make games as it is right now. I know you saw Block Dude, but I trust me, they aren't all that complicated. It's genuinely extremely impressive. So a lot of it was being able to take. Just the issue is being able to turn a really, like, you don't know anything about the block structure, take it and then make that valid Python code somehow. Would it be really easy if we weren't using Python? I'm going to be honest with you. I have to do a lot of like managing indentation. So sometimes a custom block will be nested in a way that Blockly doesn't expect, and I have to manually find those and shift those around or replace things in the code. Really annoying. Lot of making nice between ES6 and CommonJS so that I could use the same block definitions in my compiler as well as compile the Blockly editor. No documentation on any of this, by the way. They didn't write any of this. Yeah, it's a lot of code. I could absolutely show that to you right now, and I would be able to talk a lot more about it. But it just expresses itself in a very complicated project way. It's not something that the user sees beyond, oh, cool, they added a block that lets me move a guy. That's pretty much all they see on the
Okay, I do have one question.
Yes.
So, I know that you all completed the continuous integration, continuous deployment, extra credit. And considering how polished and ready this app is, do you feel that there was a direct influence from having those tools, and can you explain what those were that like helped you maybe speed up the process of developing?
Yeah. So our project is designed to be run on the Pi, right? And running stuff on the Pi is kind of an issue if you have a pretty complicated project that needs a lot of stuff to run. Our CI/CD builds a full operating system image with our code every time you make a commit. Because of our time invested setting that up, it was like 2 weeks trying to figure that out. It did become really easy to just download an image, put it into the Pi, log in for the first time, and then you have a blast pad. It meant that we had a lot of control over how we wanted the first startup experience to be, what we wanted on the blast pad from the get-go. Let us test really easily if, like, for example, this started up right into the UI. There was a long period where we had to just go into terminal and then start it ourselves and connect to Wi-Fi through Raspberry config. As we built more tools and added more functionality to the UI, slowly felt very satisfying to just get rid of the little terminal and boot straight up into the custom UI we had made. Definitely improved development a lot, I would say. Question?
We didn't test it out yet. We have any issues with that? Oh, yeah, it's hot. It's hot though. We were considering getting a heat sink, but we didn't make designs for any. So I'm gonna get you all one moment.
You work on a large project. There's a lot of time code. You're a big team. Where you prepare?
And self-serving question for some stuff, right? What have you learned from your major before, and what have you had to learn you to manage to be successful in this project?
Do we all want to answer this?
Yeah, we're target constructors. Any of you guys take the target?
Yeah. Wait. Oh, wait. You, me.
I didn't. You guys can.
Are you prepared?
Go ahead, Neil.
I think yes. Obviously, we're using a different like team management suite than we did in software design. I think in software design we had like whatever GitHub's Kanban Jira thing is, GitHub project. I don't remember what it's called. But it's pretty much the same thing. You divide up tasks, you point them, you add difficulty, and then people just take them and hopefully do them. I felt very prepared. Obviously, there's like beyond team management stuff, there's a learning hurdle with integrating hardware. People might not be super comfortable with Git, but that's, got to get that ironed out. I think it worked out pretty good. I think software design set us up pretty nicely.
Yeah, I also feel the same way. Your class specifically, I think, helped a lot with preparing us for this class. And it was, as Neil said, basically the same concepts, but we just had more time to work on the project. And this class, I guess, a bit more writing intensive. There was more documentation that we had to deal with. But overall.
Yeah, I think software design really did prepare me for this class. The team building was excellent in software design. I think one of the most notable differences was when we migrated to Jira, one of the things we noticed was you can't assign multiple people to one ticket. It was one person per ticket, so it's one person's like sphere of responsibility per ticket. And yes, there was some adjustment to that because we were really used to doing multiple people on one ticket in software design, but that kind of worked because I guess we were really good team members. So that really carried over into Capstone, and I think we were really prepared.
Documentation. Documentation, yeah. Not even anything like, obviously, writing documentation isn't terribly difficult. Effectively writing documentation is difficult, and it's going to be different depending on your project. We have Sphinx in here, like we have auto-generated Python stuff. Not really applicable at all. If I were to go back and write documentation again, I'd have probably done it 3 times. I would have redone the class diagram at least 3 times, reflect what we have now, actually document the code that we have instead of the idea of the code we would like. Yeah, I don't know. And maybe use some other different kind of auto generation framework. I don't know.
When you talk about the documentation, is it more of the fact that it's a living document that you're editing throughout the project that makes it more difficult with software design? Or...
Yes, absolutely. Yes. Yeah, because then it's like, we produce all these artifacts and our project is changing very rapidly. So it adds like 8 story points worth of stuff to do every sprint or 2.
Now my self-serving question, I'm just gonna bounce off. Docosaurus.
I love it.
Love it or hate it?
I love it.
Yeah.
Both are documents.
Oh, yeah.
I want to show them the logo.
Oh, do you feel that having the documentation within your code instead of in maybe a Word document is more beneficial, or do you feel like it's just a thing that I just added for no reason?
No, keep it in the code. It's good.
Yeah, so as far as like testing goes, part of I think what we were supposed to do is like kind of implement TDD or like we testing as we're developing around. I can get on my testing, I'm having to write all these tests. I can to perform some kind of TDD, like recognizing like cases where it pops up and stuff. Did you guys do TDD or are you going back and
we didn't do test-driven development. We added the test retroactively after the fact that we were. Yeah, I would say one of the biggest difficulties with that is trying to do like too many new things at once. We were trying to project manage for the first time in Jira, like do real sprints, as like we talked about, where you have tickets and you can only do your tickets. Trying to story point and all that, manage all that. Like creating the tickets itself was a whole like lesson. Learning how to write issues that were clear, legible, and all of that. There's so many project management things we had to do. And then with our complex project being all over the place in terms of stack, the test-driven development kind of got put to the side.
Yeah.
But it's something that we really improved on the other things. Project management.
I would also say that test-driven development doesn't necessarily benefit us that much because you know really fast if something doesn't work because the whole thing doesn't work. If one thing in your software suite doesn't work, then you get nothing. I'm not even able to launch into the thing and play a game because it hits every part of our app. It's normal use.
Do you feel that, again, sort of again to Professor Latar's question, could software testing like unit testing, like should we expand on that more?
Yes, absolutely. Yeah. If I had been I spent like another day on this. Our tests, these are kind of messy. What I would have loved is to have been forced to containerize it. This is something that lends itself perfectly to containerization, where we have an image already, but let's just containerize our code, open up some ports, run actual live testing on it. You can wrap that in Jest or whatever you like. That's a way cleaner way to test it than what I'm doing right now. There's tons of like nice little clean testing principles like that I don't know or explicitly addressed And I think would make testing something fun to do instead of what a lot of people seem to think it is. It's like, oh, I have to verify my code that I know is works, instead of feeling like a cool container guy.
All of your spreads, were they up to you?
And they were 2 weeks according to the class, but I'd say more often than not, they worked out to be like a week and a half for us. It took a lot of extra time for sprint planning. I don't know if
Could
Applebaum
you
was
talk
part of that.
more about like, because I know we have differing opinions on 1 week versus 2 week sprints. How the difference between the 2 week and the 1 week sprints you feel would be different. Like we've had like a lot of sort of debate.
There were some times where 2 weeks, like the entire scope of what we were working on changed halfway through the sprint, and then our 2 week plan falls apart. So maybe it's just like the 1 week would have allowed us to like change things more dynamically and on the fly, especially where we had a lot planned out, but we had a lot to change the UI architecture. One language and one package, they're completely different language.
Yeah.
It's also like you're catching up with people more often, so you know what they're doing or what they're not doing, and then like you have like something taking too long, you're aware of it.
I don't know if that really matters. We all saw each other when we came to class, so we had frequent meetings anyway. Okay, yeah, that's our group. That is our group.
I mean, like in my classroom, there's like built-in stand-up, like within the classroom. So like you have to come in, do your stand-up meeting, look at the Jira tickets and the Kanban board and things and talk. So the 2 week sprint for stand-up meetings isn't really effective. But the scope of what you're thinking about is like, okay, I have 2 weeks to work on something. What are the things that we're going to work on within those 2 weeks? And oftentimes maybe you'll like either try to overproduce or underproduce. But I noticed from seeing this class taught with 1 week sprints in the past where it just induced panic most of the time, because you would just say, oh, we have to get like the whole project done in a week. We have to do this, we have to do that. And yeah, things would change, but things change no matter if you're doing this with 2 week increments or 1 week increments. It's just that 1 week increments kind of put a little bit more pressure on you to deliver very, very like frequently.
I was gonna say, I think the class could benefit if we had dedicated planning time just for a few days, any amount of time.
Yeah, no, I'll also say I don't want to move on to another question, but I will say that in my mind, 1 week sprints in the beginning, 2 week sprints after you work out the kinks and figure out even if you want to include certain aspects of your project. 1 week is, I mean, you can do it with 2 weeks, but you're just gonna have a messed up burn down chart, and that's really sad to look at your burn down chart and see that it goes up in the middle of the week, and it's like, no one wants that.
Yeah.
So 1 week seems more agile. Anyway. More questions? I love talking.
Yeah, we're pretty proud. Yeah, we put a lot of sweat and burnt skin into this.
Yep. Hot glue.
Yeah, a lot of hot glue inside this case.
Do you have a favorite moment from development?
I don't know. Playing the games you guys created, that was awesome. I was kind of expecting, like our first game was a pretty simple like platformer running swipe, but then they got more complex and more complex and more complex. The tile sets and all. I recreated like the Legend of Zelda like opening stage on my own blastpad device, like sprite by sprite. That was fun. So just the whole thing, like diving back into
Getting everyone like getting a message every once in a while that says, "Oh guys, try my new game." It like made my heart flutter a little bit because I was like, "Oh my god, it's easy to do it, and people want to do it, and then I can just play it."
Once the community hub started, we started pushing games to that. We stopped like sharing them on Git, and then it was like magic. It's like, oh, I have this game, and we don't have to pull request it. We had I did this really strict rule that we had 2 approvals before pull requesting the name, so we could just see games just fly through the community hub. And we didn't have to do the pull request alone. That was like a magical moment.
How did Flappy Bird not make it into? They had their first demo was Flappy Bird. And somehow I'm seeing it's not there anymore. What happened to Flappy Bird?
Well, I'm gonna be so honest with you. That's like none of those blocks exist anymore. That was done. The complexity of that original Flappy Bird is what Block Dude looks like now. it was like the exact same amount of blocks for that, for just like a bird moving and two things that moved to the left.
Wow.
So it could have been recreated. We wanted to do something a little more complicated.
I
than that.
enjoyed these a lot more, but
Yeah, a little better, a little more impressive, I would say.
Question. What is the, like, if you were to build this again, what would be the approximate like total cost?
Well, so are we building like one? Okay, so if you're building one, it's, I would say Raspberry Pi is about like $45. The case and buttons might cost you, if you have your own 3D printer, might cost you like $5 to make it. It's not hard. And then the display might cost you around 50, and the switches are really cheap, so like a little under 120 total. We added in like the sensors we wanted to do, and you start producing this en masse. You could even just ditch the Raspberry Pi entirely and make your own like embedded computer, embedded system. You could get the price down below 100 pieces.
Oh, something else that we were actually considering was actually making it a kit. So people buy their own stuff and they create the blast pad based on the instructions we give them.
Yeah. I like that. I want to make my own.
Thank you guys for joining us.
I'm gonna say line. What?
Well, I'm just so incredibly proud of all the projects in this section. They were fantastic. Thank you all for coming. I'm seeing a lot of students, and of course, thank you, Dr. Kwatny, for also showing. It's amazing. It's awesome to see your support. Yeah. So yeah, great job. Have fun. I'll see you at graduation. None of your failing.
Use your lab.
Oh,
Used in this, so
we just trade. What? Yeah. What?
The Pi.
Oh my God, it is warm.
Yeah. Oh yeah. Where's some gloves? There's no battery component.
Oh, there's no battery.
Yeah, the battery thing didn't work out.
The Pi sugar didn't work, really.
Well, the connector broke off of it, and I tried to resolder it, and it was jank. And like, I was like, I'm not going to short the battery or run the thing yet, so I'd rather not have a little.
How many did we get? We only got one.
I only got one. The board is actually still attached. The sugar board itself is still attached to the Pi.
Oh, but the battery.
The battery just can't connect. The just to connect.
What? Yeah, I have a bunch of I have the kit to make those. We just fix them.
We could.
Yeah, but that's pretty. It was pretty cool.
That's what
It's just pretty going. Yeah.